Hello and welcome to the BI WizKid YouTube channel. In this video we're going to look at Performance Analyser within Power BI. Now this is a great tool to diagnose any slow running reports, or if you've got any performance issues with your reports, then this is a great tool to use. We'll go into the details of how to get it set up, how to use it, how to pinpoint the issues that are appearing within your reports. Our resident professional who's on this call, Sumit Gupta, will take you through two different sets of models and comparing the differences in terms of the analysis and performance between the two data sets, showing you how you can analyze the data between the two to try and understand how to make one perform better than the other. And we'll be looking at data models and data sets to understand how best to bring your data into the report to be able to get the best out of it on the front end as well. Now, if you haven't already, please subscribe to the channel. Please like, share and comment on the video. And so without further ado, let's get on with this. Using Performance Analyser within Power BI, coming up right now. Hashtag BOAT.
All right, thank you so much, Cheb. Welcome once again to everybody, whoever's listening to me and watching my screen right now. This is Sumit, as you guys know, and today I'm going to be talking about performance tuning in Power BI. First of all, Power BI really is a pretty tuned application in itself. It really does a lot of things and it's pretty tuned. You don't really get into a lot of challenge in terms of making the tool work fast. It's already quite tuned, but then there are still few tricks which if you apply, things are going to be even faster. Things are going to be even performance improved. So some of you guys probably might just want to go ahead and try some of the things that I want to show you. So let me just quickly take you into the agenda that I have in my mind today. So of course, performance tuning. I'm kind of breaking that into two different sections. One is the data level performance tuning, and the other one is the Power BI level performance tuning. Point number two is basically where I'm going to take you into certain demonstrations I'm going to show you as well. But then point number one is little introductory theoretical part, I would say. So data level common techniques are something which is not Power BI specific. Mostly you can say that it's something which you apply and it's going to be working pretty nicely across any tool, whichever tool you use. But then in Power BI, if you really want to get more specific to the performance tuning and optimization techniques in Power BI, that's point number two where I'm going to be taking you. So let's just start with the common techniques. So here we go. Many other things you guys probably know it already because if you really belong to the world of business intelligence, many of these things might be known to you already. So it says taller and narrower tables are faster, which simply means I've got an example over here down below. So the point that I'm trying to make over here is that if you have way too many columns, like the example just shows 4, that's not a problem really. But then typically if you have in your data warehouse like 30-40 columns, that's like a very wide table. If you actually go ahead and make some way in which you can transpose the data in Power BI, you can do that. You can apply certain transformations to transpose the data. If you do it and then increase the number of rows and reduce the number of columns there, that makes it a taller and narrower table, which is always going to be performing much better. So here's a little example here. So I've got the sales, cost, and unit sold. These are the 3 different numeric columns here. So if you just go ahead and you don't really expect a data warehouse to have data designed in this fashion. You don't really expect that, but then you can probably get the data from the warehouse, which is in this form, transpose it in Power BI, and then construct it like this, where you've got all the column headers over here in the row headers, and then you've got the corresponding values over here. This makes the number of columns to be reduced. It increases the number of rows, but that is still going to be better in terms of the performance. And that's a first of the 3 common techniques that I'm going to be talking about. So try to use less number of columns, more number of rows. That's the idea. Then moving on, integers are faster than strings. Well, again, no points for guessing that. I'm sure you guys know that already. So here's one example again. If you have a table over here, which looks like this, right, where you've got the product name, just remember there's no key, there is no primary key, there is no no column which identifies each row of your data uniquely using a number. You don't really have that kind of a column, a key column. If you have that situation, then if you really run a report based on this table, the one that looks like um, this one, then it is obviously going to end up doing a string comparison. And whenever you get into a string comparison for all these old database guys, I'm sure you guys might be raising your eyebrows saying that, hey, who does that? Well, definitely don't. You definitely don't want to do something like that, because it is going to be doing a string comparison, which is going to be performance wise much slower as compared to what it would be if you do this, right? So if you just change that table a little bit and then apply this product ID, which is a key column, it's the primary key, then if you actually run the same report based on this table on the right, then it's not going to, it will avoid doing the string comparison simply because it already has a key which identifies unique rows of data. Right. So the moment it's also going to be very easy if you're going to go joining these tables with some other table. Maybe if you this table has a relationship with some other table maybe, so the joining is also going to be much faster, and then there's not going to be any string comparison happening in the report level at all. So integers obviously are always going to be faster than strings, is the point that I'm trying to make. That's the second technique. And then the third one is a little more towards Power BI. Oops, I skipped one more slide. Yeah, so this is the third one, where it says that if you really have slicers, you might be wondering what exactly are these boxes on the left. These are slicers. Okay, I've got as many as 6 slicers, and then this is the visualization on the page. And then whenever you make a selection from this slicer, it actually shows that particular selected value and applies that as a filter on your visualization, and then fetches the data and plots it over there. And not just that, when you make a selection on one slicer, all the other slicers are also going to get filtered. Which means what? If you really have way too many slicers, then every time you make a selection from one slicer, it is going to go ahead and do a complete table scan and select which data is to be shown on the other slicers. So many different tables, and every table is going through a full scan. Doesn't sound like a good idea, does it? And it actually isn't. So if you're using slicers, that's a fantastic thing to just go ahead and narrow down your area of analysis, do more focused analysis. That's what slicers are used for, which is a great tool. But then too many of those, well, not really a best idea, because every time you make a click, everything starts refreshing, every table starts getting scanned, and then populating the relevant data that you choose might just take a little extra few seconds. And when I'm saying that performance, you're tuning the performance, trying to improve the performance, it's a matter of few seconds. Okay, it's a Power BI. That's why I said it's pretty tuned application in itself. Even now, when I'm going to be getting into the next section, I'm going to show you how much time it really takes to perform a particular action. It's going to be noted down in the Performance Analyzer tool. You will see the difference. It's just a few milliseconds, so it's not a huge difference we are talking about. So these are the 3 common techniques, I would say. This one was a little too close to the Power BI. The other 2 are quite generic in nature. But if you do these things, obviously, it's going to be improving your performance and getting you a better reporting environment. Then, talking about the section number 2, which I would like to take you into, where I'm going to show you a demonstration as well in just a couple of slides next to this. Um, Improving the speed of data load. So when you're actually going ahead and loading the data, or then putting it up into a report, there are certain nuances. We are going to be showing you, I'm going to be showing you rather 3 scenarios, and I'm going to create a simple report, a grid report with just an item and a quantity sold, these 2 objects. But at the same time, I'm going to try and build that report thrice in 3 different ways, and we will try to monitor how much time it really takes to perform that or run that particular report. And you will see some of the ways are actually going to be faster than the others. So to notice how much time it takes, we will definitely go ahead and use the Performance Analyzer. And then these are the 3 scenarios that I'm going to be talking about, and I'm going to be even demonstrating creating a report which requires joins. And all the database guys, again, you guys might be saying, okay, joins, not a good idea. It definitely has a negative impact on your report. Then creating an aggregated table using DAX function so that it does away with the join requirement. And then finally, we are going to be going ahead and importing the data from a SQL server using a query of my own, rather than trying to do the aggregation using Power BI and doing the aggregation using Power BI in the tool. I'm rather going to be doing that, the join and aggregation at the database level, and bring the aggregated data directly. So that's going to be the third scenario. All right. So this is a little screenshot of how the performance analyzer looks like. Obviously, every time you actually go ahead and make a click, it basically shows you the timings in milliseconds of this kind. So it's basically broken into data query, visual display, and other manipulations. So how much time these things took, it actually shows you the milliseconds of each. And I'm going to be using this particular tool to show you how much time each one of my scenarios take. Okay, so I'm not really talking about this too much. I would like to show you rather. I'll just go ahead and into the next slide, which is what I'm going to be showing you to construct an output like this. My final objective of all these three scenarios is going to be to go ahead and produce this output, where I'm go ahead. I'm sorry, going to go ahead and get the item name and total quantity measure. And the item name is basically going to be fetched from a table called as lookup item table. Okay, I've got a SQL Server database sitting in the back, which is going to have this table, and it has got 360 rows of data. Similarly, I'm going to get a measure created, which is called as total quantity, and that is going to be done on a table called as order details table. And as you can see, it has got more than 800,000 rows of data. The reason why I'm actually giving you all these details simply because just imagine if I actually get these two columns in one report, what's going to happen is that just to produce an output of 360 rows of data, the system will have to go ahead and scan these many rows of data, right? So that is going to be just to produce 360 rows of data is going to scan more than 800,000 rows of data. So which is obviously going to have certain impact on the performance. So what are the three scenarios in which we are going to be producing this output? These are the three scenarios. So the first one, which is going to be supposedly the slowest one, which is where this is a SQL Server database I've got right at the bottom. Okay. Pardon my handwriting, it's not the best. So I'm going to be getting two tables imported into Power BI. And this is going to be the lookup item table and the order details table that I was talking about in the previous slide. And then from each one of these tables, I'm going to pick up one column each and put it into the report. All right, which means that over here, it surely is going to perform a join. Okay, that's my first scenario, supposedly the slowest one. Then in the second scenario, we're going to be building the same report output, but this time we are going to be getting the same two tables from the SQL Server database. But instead of picking up the columns from these individual tables, we are going to be creating another layer of abstraction, which is this in Power BI, which is going to be an aggregated table. It's going to be a consolidated table. It's going to pick up the data from both the tables, base tables, and create a third table of its own, and then the report is going to run on the third table, which is an aggregated table, which obviously is going to be a little faster than the first scenario. And then the third one, because it's not going to have the join anymore, this is all operating through a single table, no join needed. And then the third scenario is where I'm not going to be importing these two tables at all. As a matter of fact, I'm going to be using a query of my own to create an aggregated table directly in the SQL query and then fetch only the output of that query, which is going to be a single table, and then run that report based on that one table. In each one of these scenarios, I'm going to be creating that total quantity sold measure that's going to be common across all. The table is going to be common across all. The output that I'm going to be generating going to be common across all. I'm going to be every now and then when I run a new scenario, I'm going to be going ahead and deleting the cache. So let me just go ahead and take you into the demonstration. Okay. Right. And while let me just load up Power BI as I'm doing it, let me just talk about the fact that scenario number 2 and 3, there are times when it can interchange. 2 is going to be slower than 3. Ideally, theoretically, that's how it's supposed to happen. But then there are times when the scenario number 3 might actually appear like slower, and the 2 might appear a little faster. That little interchange can happen simply because when you talk about performance optimization, like I did mention a couple of times, Power BI is quite an optimized tool itself. But when you go ahead and do certain manipulations, if the number of rows of data is not really huge, so sometimes even the scenario which is not the best one may also perform better. So, but theoretically, what I told you right now on the slides is exactly how it's supposed to happen. It's exactly, 9 out of 10 times, the scenario number 2 is going to be slower than scenario number 3. 3 is going to be the fastest. So let's see how those things work. So quickly, I'm going to go ahead and click on SQL Server, and and I'm going to put my server name, and I'll give the database name as well. And then I'm going to hit OK. Let's just wait for this thing to come up. Okay, that's my database and all the tables. So I'm going to get the lookup item table, 360 rows, remember? That's my table. And then I'm going to go ahead and pick up the order details table and just hit load. It's going to take a couple of seconds, so maybe a little more than that, to fetch all the data, and it's going to automatically detect a relationship between these two tables as Power BI does it on its own. The auto detect is pretty effective and accurate, and it has got an item ID column, which is common in both. So let me just quickly go into the model view and check if the relationship is there, and it is there. Item ID, that's what's joining on. So I'll just go into the data view, and quickly what I'll go ahead do is in the order details table, here's my quantity sold, and I want to go ahead and create a simple measure, and the measure is going to be just summing up this column. So let me just do that real quick. I'm going to call this as total QTY, sum of quantity sold is basically what I want to do. And then I'm going to hit enter. Pretty simple measure, nothing complicated. Quickly, let's jump onto the report view, and I'm going to create a simple grid visual. So I'll just take this table, let me make it big. And then before I do anything else, I'm going to go ahead and click on view and then click on Performance Analyzer. This is a tool which is going to be showing us how much time it's really taken. So it's going to, you know, note down the time of every click that we are making. So I'm going to say start recording. You'll have to start the recording so that from that point onwards, whichever click you make, it starts recording it. So now it's recording. So I'll go into the lookup item table, and I'm going to pick up item name, and see it's going to show me how many milliseconds. And then I'm going to go ahead and pick up the quantity, total quantity measure that I just created. And then it says 259 milliseconds. So I'm just going to say stop recording. That's all I wanted. Here's my visualization that I wanted to create. Okay, item and quantity sold, pretty simple. And then let's just go ahead and see how much time it really took. 259 milliseconds. I'm going to make a note of it if you don't mind, because I want to go ahead and make a comparison of these things. So I already got this Excel sheet. So I'm going to say 259 and okay, hope I done it right. Yeah. So 259 milliseconds of time it took to produce this output. Let me just close this. Let me remove, that's scenario number one. Let me just remove this measure also because I don't want to use it any furthermore. Okay, delete this. And I'm going to get into scenario number two now, where I'm going to create an abstraction layer. But before all that, first of all, I'll go into File, Options and Settings. And I'm going to go into Options and make sure that I just click on Clear cache, because I don't really want the cache, because every time you are executing a report, a cache is generated. So the next time it's obviously going to be faster. So I want my scenarios to be the contributing factor for the performance improvement, not really the cache. So I just want to clear that every time I start a new scenario. So in the second scenario, let me just quickly get into the data view, and I'll go into a home. And in home, I'm going to say new table, because I want to create an aggregated table. Remember, I'm going to call this as aggregated table, and I'm going to use the summarize function. I'm sure you guys must be aware of it. So the order details fact table is basically what I want to go ahead and aggregate. I want to group by the item ID, so it returns me only 360 rows of data, and I want the measure column to be called as let's say QTY sold. And then the aggregation function that I want to use is sum, quite obviously, in the order details table, and that's going to be the Q device sold. Close the bracket, hit enter, and that's going to return me a table. Okay, and that's going to have like two columns, item ID and quantity sold, 360 rows of data, which is fine, but the job is not done yet, because if I want the item description, I don't really have that over here, so I'll have to look up that value as well, so that this table becomes self-sufficient to run the report. I don't really have to go into any other table then. So I'll just quickly go into home, new column, and I'm going to call this as item description. and I'm going to use the lookup values function, and then I want to look up the item name from the lookup item table. This is what I want to pick up, and it's going to ask me for the common columns in both the tables, which is the item ID. And in my current table also I have an item ID. So this is the one which is going to be used for the join. And there we go. I've got all the item description. And then finally, one last thing before we head back to the report is I'm just going to create that measure of summing up the quantity sold one more time like I did last time. So total, oops, total quantity, and it's going to be a simple sum of quantity sold. That's that. So I've got this third table now, which is good enough to run the report on its own. So let's just head back to the report view, take the grid, and then one more time, I'm going to be enabling the performance analyzer. And let's just go ahead and see how much time this one takes. This is supposed to be a little faster. Okay, so I don't really need the other two tables anymore. I'm just going to take the item description from here, the aggregated table we created, and then I'm also going to take the total quantity from the same table, and then I'm going to say stop recording, you've done it enough. Right, now the same output, but now it says 223 milliseconds, which means if I go back to my Excel sheet, that's 223 milliseconds, obviously lesser than the first one. So let me put down the other ones as well. And that's the breakup. So you see, this one, scenario number 2, has been faster than the first one overall. Okay, so these were the two scenarios I wanted to show you. Let's just head back, and I'm going to delete everything now, and I'm going to show you the last scenario. Okay, so let me just get rid of these tables as well. I don't really want to do any of that stuff that I've been doing so far in Power BI. I'm just going to simply write a SQL statement and bring the data from that SQL statement. And that's going to be the last scenario, which is supposedly going to be the fastest one. But like I said, it's possible that it might just, the second one might just appear to be a little faster, depending on the processor speed, depending on the amount of data. Power BI really can handle a lot of data. So if your data really isn't that large, these scenarios might not exactly impact the way the theory says. So first of all, let me just go into File and do this thing, clearing the cache, because it might have produced a cache again. Okay, it didn't. Okay, I'll just say hit OK. Now that's fine. What I'm going to do here is I'm going to show you this SQL statement. This I've already written it for you. So SQL Server, this time I'm going to be fetching the data from the same server, same database. But this time I'm going to go ahead and paste the SQL statement. So let me just talk about this a little bit. So I'm selecting the item name column and the sum of quantity sold column, and I'm going to put the quantity sold as, display that as quantity sold. And I'm going to get it from the lookup item table, and I'm going to make a join on the order details table using the item ID, which is the common column. And finally, I'm going to go ahead and do the grouping by the item name. So it's going to return me the item name and the numeric column, which is quantity sold, and that's all it's going to return from this particular SQL. So you see, the join is already implemented, the aggregation is already done, and the output is what's going to be imported into Power BI. So I'll hit OK quickly, and it should basically go ahead and show me this table, which is what I was expecting. Hit load, only 360 rows of data, let it load, and there we go. It's there. So if I just go into the data view, this is what it looks like. I'll quickly create that measure, which I've been doing as the common step, and then quickly go ahead and put it into the report. So that's that. Sum of the quantity sold column, and I will get into the grid view, and we need to go ahead and enable the performance analyzer, of course. And I'm once again going to say start recording, and it starts recording. Now from the single table, I'll just take the item name, and I'll also take the quantities sold. And then I'll say stop recording. So this time it says, again, same output. This time it says 182 milliseconds. So like I said, see, this one is the fastest. So it says 8 and then 69 and then 104. So you see, this is basically what I was trying to show you, that this one has turned out to be the fastest. This was a little slower than that, and this was the first scenario, which was the slowest of all. So the thing that we did differently was, on the first scenario, we actually let the join happen. The second scenario, we created an aggregated table, but we did that in Power BI using DAX. And then in the third example, we actually created the same aggregated table, but instead of doing it in Power BI, we did that in the SQL Server environment itself. So these were the three scenarios that I wanted to show you. And as we had talked about earlier, the third one comes out to be the fastest one. So, and that's pretty much it that I wanted to show you guys. You can apply that if you really like it. You can apply this in your own project, in your own report. If you have any further questions, you can actually reach out to me on that contact details, which is flashing on your screen right now. And I'll be more than happy to help you guys. So that's all from my side. I hope you guys enjoyed this, and I hand it over to Sheb again.